Hi, so in this video, we're going to differentiate the function artanh of 1 over x. So yeah, this is very similar to other inverse hyperbolic functions that we've done where we've got this reciprocal function inside the hyperbolic function. Obviously, just a note, it should be clear that x can't be equal to 0. And in fact, let's just investigate the domain of this function and the range of this function a little bit further. And to help us do that, we can just look at the y equals artanh of x graph first. So y equals artanh of x. So if we sketch a graph of this, we should get something like this. So obviously our x-axis there, y-axis there. So we get asymptotes between -1 and 1. And the artanh function kind of looks something like this. So it tends to infinity as x tends to 1, and it tends to negative infinity as x tends to -1. So something like that. So we can obviously see that the domain of this function is modulus of x less than 1. So that's our domain. And we can also see that we've got a range of negative infinity up to positive infinity as our range. Okay, cool. So then we can use this information to help us work out the domain and range of the artanh of 1 over x function. So for artanh 1 over x, so it must be true that the range is still the same. So range is just still the same as the original function, because the range of the artanh function never changes, or any function that you work with for that matter. And okay, so now we know that the range must be this. So the modulus of 1 over x must be less than 1. But that's just exactly the same as saying the modulus of x must be greater than 1. It's just exactly the same as saying that. Okay, so we know the domain for the artanh of 1 over x function is that, and the range is that there. Okay, so this may be useful later on in the video, but let's get on with the differentiating. So to differentiate the artanh 1 over x function, so again, it's going to be the chain rule. So you've got a function of x. So the artanh function of the reciprocal function of x. So just by using the chain rule, we get the following. So the derivative with respect to 1 over x of the artanh of 1 over x function multiplied by the derivative of 1 over x with respect to the variable x. Okay, so that's just by applying the chain rule, and we've done that in previous videos, and you can watch some of my previous videos to see in more detail how we can use this chain rule. So that's the chain rule, or by the chain rule. So then if we differentiate this first function with respect to that variable there, well, we know from a previous video that I did that when you differentiate with respect to x, the artanh of x function, you get this result here. So you get 1 over 1 minus x squared. And just to remind you, so the artanh of x function is only defined when the modulus of x is less than 1, like that. So yeah, so that's our derivative there. So if we just change the variables here, because we don't want to differentiate that function, we want to differentiate this function here, the 1 over x, the artanh of 1 over x function with respect to 1 over x. So we just swap the variables. So swap that x with the 1 over x like that. Swap that x with the 1 over x like that. And swap that x over there with a 1 over x like that. And again, we can just tidy this up a little bit. Let me just move this to the side over here. So that's our domain. Oh yeah, of course, you've got to swap the domain as well. Sorry, I should say we've got to swap this to a modulus of x greater than 1 now. So now this is going to be equal to 1 over 1 minus 1 over x squared. We can multiply the top and bottom of that fraction just to make it look a bit nicer. And if we do so, we get x squared over x squared, subtract 1 like that. Okay, so that's our result, and we can plug that in to the first bit here. So we get x squared over x squared minus 1. And then we multiply that by this derivative here. So the derivative of x to the, well, 1 over x, which is exactly the same as x to the minus 1. And we know that when we differentiate that, we get negative 1 over x squared. So we've done this before in previous videos, so you can check that out if you'd like to. Okay, so then we can just multiply the top of the fraction together and then the bottom of the fractions together to get this. So x squared on the bottom times x squared minus 1. Obviously, there's a minus sign there, sorry. At this point, we can obviously cancel out the x squareds. So you can cancel that out with that. And so as a final result, we get negative 1 over x squared minus 1. And in fact, we can actually factor out a negative 1 on the bottom of that fraction. And if we do that, we would get 1 over 1 minus x squared. So in conclusion then, so when you differentiate this artanh of 1 over x function, you get 1 over 1 minus x squared. Sorry, let me write that again. 1 over 1 minus x squared. Obviously in this domain, so the domain being modulus of x is greater than 1 in this domain. Okay, so we get that result there. Now, if you watched the previous video, we differentiated this function here. So this r cof of x function, and we got exactly the same result. So 1 over 1 minus x squared. And the domain of that function was indeed actually the same. So the domain of this r cof function was the modulus of x is greater than 1. And we did like a little sketch of that function in the previous video yesterday. So the y equals r cof function kind of looks something like this. You've got asymptotes at 1 and asymptote negative 1, and a graph that kind of does something like this, roughly. Yeah, so a graph like that. And as you can see, obviously the domain is modulus of x greater than 1, and we've got a range of, well, technically all real numbers apart from 0, but I mean, I'm just going to keep things easy and just say the range is just all real numbers. Yep, so that's the r cof function. So essentially then we've got a function here which has got the same domain as the function here, and it's got the same derivative. So the conclusion from this is that these two functions, the r cof function of x and the artanh function of 1 over x, must be the same up to a constant. So therefore, artanh of 1 over x equals r cof of x plus a constant c. And again, we have to add that constant c in, just because if we add the constant c inside the derivative there, well, differentiating a number, a constant number, you just get 0. So there could actually be a hidden constant in this equation down here. In fact, we will find out if there is or not. And we can do that as follows. So if we let y be equal to r cof of x, we can apply the cof function to both sides. And of course, when we take cof of r cof of a variable, we'll just get the variable x there, because cof and r cof are inverse functions. Now, we know by definition that cof is defined to be cosh of y over sinh of y, and this equals x there. So the key thing to note is that the cof function is undefined at, so undefined, the cosh y is undefined at sinh y equals 0. Because obviously if sinh y equals 0, then that fraction won't be defined. But the key thing to note here is that actually when sinh y equals 0, tanh y equals 0 as well. And we can actually just see that by sketching the graphs of the two functions. So if I go to another page, so if you sketch a graph of y equals sinh of y, sorry, let me do that h a little bit neater, so sinh of y. So when you sketch that graph, you get something like this. Sorry, let me try and be a little bit neater. So something like that, and something like that. And when you sketch the y equals tanh of sorry, I should put, well, I mean, really, I should put an x in there. I should put an x there. And when we sketch the y equals tanh of x function, we get something that looks like this, with asymptotes at y equals 1 and y equals -1, like so. So as you can see, so when sinh of y equals 0, tanh of y equals 0. So, I mean, that's just exactly the same as what I've written down here. So that means that, sorry, I shouldn't say cosh here. I should say coth. My bad. This is a mistake. So coth of y. So coth of y is undefined at sinh of y equals 0, as we can see by the fraction there. But sinh of y equals 0 is the same as when tanh of y equals 0. So when sinh y equals 0, tanh y equals 0. So, and I mean, if you look at the graphs, sinh of y only equals 0 at the point where tanh y equals 0. So that means that therefore this cosh y divided by sin y, or sinh y, is exactly the same as 1 over tanh of y. Now, obviously, tanh of y is the same as sinh over cosh, but the coff function, because it is defined to be cosh over sinh, we just got to check whether that is the same as 1 over tanh, and indeed it is true in this case. So for all y values in the domain, and the domain is the real numbers apart from, the real numbers apart from 0, of course. So for all y in the real numbers apart from 0. Okay, so we know that piece of information there. So let's go to another page. So therefore x, so this x variable there equals the 1 over tanh y function. Just rearrange that to get a tanh y. So tanh y equals 1 over x. So now let's apply the artanh function to both sides. So artanh of tanh of y equals artanh of 1 over x. So you may be thinking, well, on this left-hand side, well, surely that's just equal to y, because you've got an artanh there, you've got a tanh there, they're inverse functions. Surely we just get y. So yes, in this case we actually do, but in a lot of cases we don't. And the reason why is because y is not a variable. Y is a function, namely a function of x. Y equals r coth of x. So actually, we're not dealing with a variable here. We're dealing with a function. So you've got a function of a function of a function of x. So we can't just say that this artanh of y is y. We've got to check the range of this y function. So we've got to check the range of the y function, and we've got to check that that range fits in or is a subset of the domain of this tanh function in order for us to get a y on the left-hand side. So the range of y, and y equals r coth, as we can see from over there. So y equals r coth of x. So what is that range? Well, we've sketched this graph. Not there, oh, there we sketched it. Yep. So we know the range is the real numbers. Well, technically the real numbers apart from 0. So I'll write that there. And the range, well, the domain, we're interested in the domain of this tanh function. So if the domain of this tanh function contains the range of this y function, then we're okay. We don't need to worry about keeping this as it is. We can actually just cancel the artanh and the tanh out. But of course, because tanh and artanh are inverse functions, the domain of this tanh function is the same as the range of this artanh function. So if we just consider the range of the artanh, so the artanh of x function, well, we've sketched that graph over here, and we can see the range is, well, from minus infinity to infinity. So all real numbers. Yeah. So the range is all real numbers. So what we can tell is that the range of the rcof function is contained within the range of the rtanh function. So in other words, the domain of the tanh function contains the domain of the y function, and so we're okay. So what this means then is that rtanh of tanh of y is indeed just y. So we don't need to worry about keeping this all there. We can just cancel out the two functions, since the domain of tanh contains everything that y could be, essentially. So we know the left-hand side there is just y, and the right-hand side is rtanh of 1 over x. And therefore, what we can conclude is that since y equals rtanh of 1 over x, and we know that y equals rcof of x from that page there, we can therefore conclude that rcof of x is exactly equal to rtanh of 1 over x for all x values in the domain. They both share the same domain, don't they? Because they're exactly the same function. So for all x in the domain, well, in the domain where the modulus of x is greater than 1. So I'll just write that there, modulus of x greater than 1. So that result is true. So clearly they both have the same derivative, and because since they are both the same function. So yeah, this is kind of the key result from this video then. So this is true there. So the rtanh of 1 over x function, defined for the modulus of x bigger than 1, has the same derivative as the rcof of x function, where the modulus of x is also bigger than 1 as its domain. And this c there, well, that's just 0. So yeah, that's that video complete.